What if farmers could know exactly how much crop they would harvest before the season even ends? Not a rough guess, not a hopeful estimate, but a precise, data-backed prediction that could change every decision they make. Sounds like something out of a science fiction film, right? Well, that future is already here, and it goes by the name of artificial intelligence yield forecasting. AI yield forecasting is rapidly emerging as one of the most revolutionary technologies transforming modern agriculture. It is reshaping how farmers plan their resources, how agribusinesses manage their supply chains, and how governments prepare for national food demands. From small family farms to massive agricultural corporations, this technology is cutting through uncertainty and replacing it with something far more powerful, actionable intelligence. And in a world where food security is more critical than ever, that shift changes absolutely everything. Before artificial intelligence entered the picture, farmers relied on generations of accumulated knowledge to estimate their harvests. They observed cloud patterns, tracked rainfall manually, and made educated guesses based on how previous seasons had unfolded. As agriculture scaled up, basic statistical models were introduced, using limited historical data to project future yields. But these approaches came with serious flaws. A farmer's personal experience, while valuable, could not account for rapidly shifting climate conditions or regional variations across thousands of acres. Statistical models required months to process data, meaning decisions were often made too late to matter. And when it came to managing large-scale agricultural operations spanning multiple regions, these older methods simply broke down under the weight of complexity. Inaccurate forecasts led to overproduction, food waste, or dangerous shortages. It became increasingly clear that agriculture needed something far more powerful, precise, and scalable to meet modern demands. So what exactly is AI yield forecasting? In simple terms, it is the use of artificial intelligence and machine learning algorithms to predict how much crop a farm will produce before the harvest even happens. Think of it as giving agriculture a powerful brain that can process enormous amounts of information and make highly accurate predictions. But here is something important to understand. AI yield forecasting is not a single tool or one piece of software. It is actually a combination of multiple technologies working together in harmony. We are talking about satellite imagery capturing crop conditions from space, ground-level sensors monitoring soil health in real time, weather data tracking temperature and rainfall patterns, and historical crop records that teach the system what to expect. All of these inputs come together, feeding into intelligent algorithms that generate reliable, data-backed yield predictions. It is truly a technological ecosystem built for modern farming. So where does all this predictive power actually come from? It starts with data, and lots of it. Remote sensing and satellite imagery play a massive role, continuously monitoring crop health from above by measuring vegetation indices, canopy cover, and signs of stress across entire fields. Down on the ground, Internet of Things soil sensors collect real-time readings on moisture levels, temperature, and nutrient concentrations, giving the AI a detailed underground picture. Weather stations add another critical layer, feeding in live climate conditions like rainfall, humidity, and wind patterns that directly influence crop development. And then there are historical yield databases, essentially the AI's classroom, containing decades of recorded harvest outcomes tied to specific environmental conditions. Together, these four data streams create a rich, multi-dimensional picture of what is happening on a farm. The more complete and accurate these inputs are, the sharper and more reliable the AI's predictions become. So how do these machine learning models actually make sense of all that incoming data? It starts with training. Algorithms like deep learning, neural networks, and regression models are fed massive historical data sets, sometimes spanning decades of agricultural records across thousands of farms. The model learns to recognize patterns within this data. For instance, it might discover that a specific combination of 200 millimeters of rainfall, temperatures averaging 22 degrees Celsius, and soil nitrogen levels above 30 parts per million consistently produced yields of 4 tons per hectare in a particular region. Neural networks, inspired by the human brain, process these variables simultaneously across multiple layers, each layer extracting deeper relationships between inputs and outcomes. Regression models, on the other hand, calculate statistical relationships between variables. Together, these approaches allow the system to generate increasingly accurate yield predictions as more data becomes available over time. Building on how machine learning processes numerical data, there is another powerful layer at work: computer vision. This technology allows AI systems to analyze drone footage and satellite images with remarkable precision, identifying crop stress, disease outbreaks, or irregular growth patterns long before they become visible to the human eye. When a drone flies over a field, its cameras capture thousands of detailed images. AI algorithms then scan these images, detecting subtle color variations, leaf discoloration, or uneven canopy density that signal potential problems. Satellite imagery adds a broader perspective, monitoring entire regions simultaneously. This visual data does not just stay as pictures. AI converts it into measurable indicators, like stress severity scores or affected area percentages, that feed directly into the overall yield prediction model. The result is a richer, more accurate forecast that combines both numerical and visual intelligence seamlessly. Leading technology companies and agri-tech innovators are already deploying AI yield forecasting at impressive scales. IBM's Watson Decision Platform for Agriculture combines satellite imagery, weather data, and machine learning to deliver crop yield predictions across multiple continents. Microsoft's FarmBeats project connects IoT sensors with cloud-based AI models, helping farmers in regions like India and Africa make data-driven decisions. In India, AI systems have demonstrated the ability to predict wheat yields with accuracy rates exceeding 85%, significantly outperforming traditional estimation methods. Meanwhile, in the United States, companies like Climate Corporation are using deep learning models to forecast corn production county by county, giving agribusinesses months of advance notice for supply chain planning. Agri-tech startups such as Cropin and Aerobotics are expanding these capabilities into Southeast Asia and Sub-Saharan Africa, proving that AI yield forecasting is genuinely a global phenomenon, reshaping agricultural decision-making worldwide. Now that we understand how AI yield forecasting works, let's talk about who actually benefits from it. And the answer spans across multiple groups. For farmers, the biggest advantage is smarter resource planning. When you know in advance how much crop you are likely to harvest, you can make better decisions about how many seeds to purchase, how much fertilizer to apply, and how many workers to hire during harvest season. This reduces waste and cuts unnecessary costs significantly. For agribusinesses, accurate yield predictions mean smarter supply chain management. They can plan storage, transportation, and pricing strategies well ahead of time, reducing losses and improving profit margins. For governments and non-governmental organizations, AI forecasting becomes a powerful tool for food security planning. Early warnings about potential crop shortages allow policymakers to intervene before a shortage becomes a crisis, protecting millions of vulnerable people from hunger. But like any transformative technology, AI yield forecasting is not without its challenges. One of the most significant hurdles is data quality. In regions with poor infrastructure, inconsistent or missing data makes it difficult for algorithms to generate reliable predictions. Farmers in remote areas often lack access to the sensors and connectivity needed to feed these systems properly. Then there is the cost barrier. Deploying Internet of Things sensors, purchasing satellite subscriptions, and maintaining digital infrastructure requires substantial investment that many smallholder farmers simply cannot afford. Algorithmic bias is another serious concern. When machine learning models are trained primarily on data from North America or Europe, they often perform poorly in African or Southeast Asian agricultural contexts, where crop varieties and climate conditions differ significantly. Finally, resistance from traditional farming communities remains a real obstacle. Many experienced farmers are skeptical of technology-driven recommendations, preferring generational knowledge over algorithmic outputs. Despite the challenges we just covered, there is genuinely exciting progress happening on the accessibility front. AI yield forecasting is no longer exclusively a tool for wealthy corporations or large industrial farms. Thanks to mobile-based platforms and cloud computing, this technology is reaching farmers who previously had no access to advanced agricultural insights. Cloud computing allows complex machine learning models to run remotely, meaning farmers do not need expensive on-site hardware. All the heavy processing happens in data centers, and results are delivered instantly through simple smartphone applications. In countries like Kenya, India, and Bangladesh, Smallholder farmers are already using apps like Plantix and Cropin to receive AI-driven crop predictions, disease alerts, and harvest estimates directly on their phones. These platforms often work with basic internet connectivity and are designed in local languages, removing both technical and linguistic barriers. AI yield forecasting is genuinely becoming democratic, accessible to anyone with a smartphone regardless of farm size. The future of AI yield forecasting is incredibly promising, with several emerging trends set to redefine agriculture entirely. Generative AI is stepping in to enable scenario-based planning, allowing farmers to simulate thousands of possible seasonal outcomes based on shifting climate variables, helping them prepare for uncertainty like never before. Digital twins are another groundbreaking development, where entire farm ecosystems are virtually replicated to model how real-world changes in soil, weather, or crop variety might impact final yields before any physical action is taken. These virtual farm models allow for risk-free experimentation at zero cost. Perhaps most exciting is how AI forecasting is converging with precision agriculture tools like automated irrigation systems, drone sprayers, and GPS-guided machinery. Together, these technologies are building a fully connected farming ecosystem where data flows seamlessly from field to forecast to action, creating an optimized agricultural operation that responds intelligently to every variable in real time. At its heart, AI yield forecasting is not about replacing the wisdom of the farmer. It is about giving that wisdom a powerful new lens. We have traveled a remarkable distance from seasonal guesswork and handwritten field notes to satellite-powered predictions and machine learning models, processing millions of data points in seconds. That journey represents one of agriculture's greatest leaps forward. Farmers are not becoming obsolete. They are becoming more informed, more confident, and more capable than ever before. As our global population pushes toward 10 billion people by 2050, the pressure on food systems will be immense. AI yield forecasting stands as one of our most promising answers to that challenge, helping us grow more with less, waste less, and plan smarter. The future of feeding the world begins with better information, and that future is already here.